Yeah, start.
Meanwhile, I am, thank you very much, madam. So meanwhile, I am requesting all the participants, whoever is there, for example, the respected faculties and the students, kindly open Google Colab. So what I am doing, I am just sharing my screen to all of you, such that those who already know, it's fine. Those who do not know, they can open up the Google Colab and be ready, because we will have some theoretical overview. Okay, what are the aspects of the deep learning and what are the current model architectures are available, and then we will implement one or two in Google Colab. Okay, and do not worry, I will share the notebook to all of you, but it will be better that if you join with me in the hands-on session actively, then it will give all of you a lot of confidences. Those who are expert in this field, that's fine, but those who are new to that field, it may be quite confidential, confidence booster for them. Okay, so let me share the screen. Can you see the screen? So those who already know,
Yes.
it's fine. For thank you very much, madam. So those who are new, you just type Google Colab, okay, and then click on Welcome to Collaboratory. Okay, so it will open. Once it opens up, click on New Notebook section. Okay, so it will open up the new notebook for all of you. Those who know, it's fine. Those who are new, please type in Google Colab, okay, and then click on the given link. You see in the bottom section of this pop-up, there is a new notebook section is there. Click on New Notebook. So you see this type of notebook will come up. You may give some name in this area. Untitled 7 it is showing. You may add some name. For example, you may add here AlexNet practice. Just for example, you may give some type of name here, and you see in the bottom section of this, here you see there are two options. One is plus code, one is plus text. Now you want to add up some text, you can click on plus text and you can add there. Plus code is all about writing the code. You will write the code there, and then you can see there is a run cell button is there. You will click on the run cell and the code will run. Okay, now I am going back to my original notebook, where which one I will share with all of you. So basically, today we will cover up the few modern new architectures, but those who are new to this particular field, just let me share a few things with all of you. First of all, what is the requirement of this type of, nowadays you all of you are hearing a lot of terms like data science, AI, for example, new machine learning, deep learning. So what is the requirement of that? If you see that in the present scenario, in simple word, if I explain to you, especially the students who are very new to this field, it will quite be helpful for them as well. That think quite simply, simple manner, that nowadays we are recording data or storing data in digital means or mediums. We are not storing record through pen and paper. So due to that, once you are storing data in digital medium, you require a lot of flexibility in terms of the databases, because you see whenever we started, okay, from the large amount of the computational applications in offices and all those things started in all the developed countries from late 1950s, and in India it is in 1960s. So what happened that in those era, people mostly used the tabular format of the databases. Okay, then the RDBMS, and nowadays you guys can imagine, you all of you put the query in RDBMS through SQLs. Okay, but then what happened that we gradually moved towards the 90s era, and from 1994, due to the arrival of the World Wide Web, what happens that people started to explore in internet, and gradually the social media concept of the social media platforms came up in 2004. So in 2004 onwards, mainly in 2004, it was the Facebook which arrived, and due to that, all of you post images, videos there, write some text. So all these are the unstructured format. So earlier it was only in the tabular format, in the structured format data. Nowadays you started to explore in from early 2000. It was all about unstructured data sets. Even for example, whenever you are using LinkedIn also, you are doing the same thing. You are posting images, you are writing text, you are sharing your success stories. So all about the unstructured data sets. So in a combination of the structured and unstructured, you are basically generating huge amount of the semi-structured data. Okay. Now, for example, whenever you are doing some activity in LinkedIn, so your login time, logout time, and the activity time will be stored in a structured format, tabular format. But during the post, you may share some images, videos, write some text. So that is the unstructured data. So in a holistic format, it will give you the semi-structured data. Okay. So this is how the data has evolved throughout the year. Okay. And you see, there are several cases. For example, the concept of the neural network is not new. From 1940s, people started to imagine that that emulating the human activity or copying the human activity. Okay, so it's all about the imagine how can we relate it with the analogously with our human brain activity. Okay, so the concept of neuron elegant developments has been made in this particular field in terms of the, if we consider, and if we are talking about the machine learning. So we got lot of strong methods in this domain: decision tree, support vector machine. Okay, then hidden Markov model. Okay, a lot of approaches we have seen in this particular field. But you see, when we were talking about this type of the machine learning applications, which are quite effective, up to data in order of 10 to the power 4, it is quite effective up to data in order of 10 to the power 4. So that means we can call it as a shallow network. It's a kind of the shallow network. Okay, but as I was saying, that there is a surge of the huge amount of the resources from the several resources from the data sources. There is a surge of the databases and variety of the databases. Now that's the reason we are going for the schema-less structures nowadays rather than going with the rigid schema. So nowadays you can see the millions of the images are generated through the several mediums and several platforms, billions of the videos you are generating. So you see that we are now going ahead data in order of 10 to the power 5 or more. So due to that, to tackle those concepts, you require certain complicated neural network format which can tackle those surge of the data sets. Because you see nowadays the database is getting double day by day. Okay, and 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 you can see that's the reason there is so much demand of the skills like the big data and all those things. But you see that there are two things will matter. First of all, you require the math. Basically, three things matters. Basic thing is the mathematics, because mathematics is the heart of deep learning. You all of you know, and those who are new to this field, for them, just I want to highlight few things: that basic aspects of the linear algebra, it is required. Simple calculations like eigenvalue, eigenvectors, you should be able to do it. Matrix, vector multiplications, and all those concepts. Basics of the statistics should be very clear to you. Okay, basic concept like regression, logistic regression, because basics are always important. So make sure that all of you are quite adept with that. And then obviously the concept of the probability, the Bayes theorem, for example, central limit theorem, all those things you should know. And along with that, definitely all of you have to have some programming skill. Those who are basically deals with the quite frequent with these extensive statistical methods and all those things, R is a very good way of dealing with it. And apart from that, Python is a very elegant tool to use with. Okay, because you see, first of all, Python is a cloud communicator language. Secondly, all the deep learning frameworks are highly Pythonic. Whether you are talking about the Keras, MXNet, TensorFlow, PyTorch, everything is a highly Pythonic. Now, what I was saying, that first of all, the mathematical development. So in 1980s, when the mathematical development of the deep learning was happened, nobody was quite sure that whether they will be able to deploy it in practically. So with the limited resources in 1988, the Linnet paper came up where the Ian LeCun, one of the godfather of the deep learning, they proposed a Linnet, okay, a deep learning architecture which can classify the images in a handwritten digits basically. They explode it on the handwritten digits quite elegantly. But you see, still the Linnet has a lot of limitations. Even the support vector machine, which I was highlighting earlier, that is one of the elegant method of the strong elegant method of the machine learning, they are basically overshadowing Linnet. So there was not much promising development of the deep learning because machine learning, especially SVM, was huge popular then, and they are alone. They are basically ruling the kingdom of this type of neural networks. And Vapnik, due to that, one of the godfather of the SVM is the Vapnik, he got huge popularity due to that. But what happened that, as I was saying, that the new source of data is being generated, number of images, videos, there is a surge of data sets, and it started when people explode in the internet age and the social media age, and due to that, and new type of the database supports came up, and in 2007 first deep learning framework in the form of Theano it came up, but then it was completely on the base of the symbolic programming. Okay, in 2015 we got TensorFlow, followed by 2016 PyTorch. Academicians mostly prefer PyTorch because of their imperative approach. TensorFlow and Theano, initial level it was in the symbolic programming format, but you see the way we used to code the imperative programming code, like we used to write if else statement, for loop in this way. So this is how we are accustomed to writing the codes in imperative mode, and due to that the academician gave a lot of priority in PyTorch. But by seeing the popularity of the PyTorch in TensorFlow in the next version 2.0, they also adapted the imperative way of coding. Okay, and due to that, whenever you are writing, giving instructions in front end, that will be in imperative mode. So for example, Python, which is a highly user friendly languages, so you can put in comments in imperative mode. In the back end it will be executed in the symbolic mode. So it's basically a hybridized combination. For example, PyTorch in back end uses C++ to make the faster execution of the codes. In the front end it is Pythonic, back end it is C++, who is actually doing all the stuffs quite in a faster mode. So this is how the software development, along with the mathematical development, supportive software development has happened. But apart from the software development, you require also some supportive hardware development as well. You can imagine the late 1980s era or 1990s era, you don't have that much of the faster executing supportive hardware. For example, there is no concept like GPUs. So in 2012, the first when NVIDIA came up with GPUs, it becomes easier for people to explore all those elegant deep learning architectures. People started to explore with all those elegant deep learning architectures, new methods, tools, and the revolution started basically. Okay, and the ImageNet competition, all of you know, where the Fei-Fei Li, one of the prominent scientists, played a very, very important role. Okay, so they basically build the ImageNet databases, because earlier we are talking about UCIs on all those database repositories before 2010. But when the ImageNet database has been formed, so 1,000 images are there, with each of the images has the 1,000 number of the features. So you can deal with lot of extensive databases. Okay, like I was mentioning that, or data in order of nearby in order of 10 to the power 5 or more. So that type of huge samples can be generated through the ImageNet. Okay, and people started to come up with the new type of the architectures. Okay, in ImageNet competitions, they are taking part of the ImageNet competitions, ImageNet large scale challenges, and those who are the winners or runner up, whatever the nowadays you hear about the new deep learning architectures, like for example here we will talk about AlexNet. Okay, there are VGGNet, okay, ResNet, and obviously ExceptionNet, InceptionNet. All those concepts are either the runner up or the winner from 2012 onwards. Okay, so then the era of deep learning actually started from 2012. We can say the era of the deep learning started, and it got the boost from TensorFlow or the PyTorch from 2015-16 onwards. And due to that, we are getting the blessings of this type of the highly computational and elegant tools and methods. Okay, so this is the basic background. I hope Now all of you are quite clear that why deep learning is important and how we are approaching towards it, because deep learning is performance wise scalable, and this scalability is achieved due to ReLU activation functions like ReLU. Okay, because in machine learning we use activation functions like, for example, sigmoid or tan hyperbolic. Those are the not performance wise scalable. Okay, so ReLU, if you look at the curve of the ReLU, it's a ramp like function. It is continuous scalability can be achieved. Okay, so I request all of you to go through the basic mathematics. If you already know behind the deep learning and all the requirements of the mathematics I told you, for example, linear algebra and all those skills, please brush up those skills so it will be better. Those who are expert present in the audience, they already know it. Those who are new, I am requesting that please go through it. It will give you the larger view. And today we will implement a couple of examples. Okay, first one is the AlexNet and second one will be the VGGNet. Okay, I will share both this notebook to all of you, so nothing to worry about it. But as of now, like I told you, that for your own confidence boosting purpose, you can type those codes by your own hand, so it will be easier for you to understand. Okay, so like I was telling that the development of the software platforms and hardware platforms gave the lot of effectiveness in terms of the coming up with the new type of the architecture. Okay, so first of all, in 2012 when the AlexNet came up, okay, which actually the modification over the LeNet. Okay, so people got a lot of expectations from the deep learning architecture. So we will see that how it looks like from the representations. So this is basically the paper developed by the Krzyzewski, Sutskever and Hinton, okay, in 2012. Okay, so they basically showed that there are ways of the deep in machine learning. What happens that we always we separately put the feature extraction tool. First of all, we make the data cleaning. Okay, then for example, removal of the noises and all those factors. We have to take care of data normalization in the next instruction. But in deep learning, it is the the architecture will learn the feature. For example, whenever you are applying some image filter of the AlexNet, what happened that the very simple features like edges will be learned. Okay, then in the next step, what will happen? The more complicated features, because the higher level of these layers, the more the complex features it will start to learn. Okay, so the missing ingredient section, which I already availability of the adequate data sets was the problem before 2010, which actually resolved through the ImageNet competitions. They first came up with in 2009 the last data sets, which was led by Fei Li, and then obviously the hardware facilities, which I was discussing few minutes back regarding the support of the GPUs. In 2012, NVIDIA came up with the GPUs. In 2016, Google came up with the TPUs, okay, and which gave the lot of flexibilities in terms of the exploring this type of the deep learning, extensive deep learning codes in those fast running machines. Okay, nowadays, for example, we are using the virtual platform provided by Google Colab, where you can run all the Pythonic platforms. You can take the help of the virtual GPUs, TPUs present there in Google Colab. Now, so basically, if you see the AlexNet architecture, so this is the comparative view of the LeNet versus AlexNet. So LeNet, what happened that 28 by 28 hand data sets, MNIST data set has been used. What you see, there are two 5 cos 5 convolutional layers are there, okay, and two average pooling layers are there, and at the end there are three fully connected layer is there, okay, and the output you are getting 10. Why? It is because 0 to 9 hand digit recognition 0 1 2 3 4 5 6 8 9. So there are 10 digits it will recognize. Okay, so you will put some unknown sample there, and you will see that whether it will be able to detect the digits properly or not. Okay, so this is overall scenario. What happens that we first train the system, okay, and then we check the training accuracy, we do the validations, and then we put some unknown sample to test it. In machine learning, what happens that 70 to 80% data set can be explored for the training purpose, and rest of the data set you can explore for the testing purpose, rest of the 20% or 30%. But in deep learning, as you have the data in order of 10 to the power 5, you can use 98% of the data for the training purpose, and you can test the training accuracy with the known sample. That is the validation, we call validation. So out of the rest of the 2%, remaining 2%, 1% you can use for the validation purpose, and unknown sample which will be used for the testing purpose, that will be another 1%. So in case of the deep learning, you can use the 98% of the whole data set for the training purpose. Remaining among the remaining 2%, 1% for the validation, 1% for the testing. Okay, but in case of the machine learning, where you deal with the hundreds of samples, 100 or 1000 maximum, so there you basically take the 70 to 80% for the training, rest of the 20 to 30% for the testing purpose. Okay, so this is how it looks like the LNet structure. Let us back with the AlexNet. But as I was saying, that 224 by 224 images was as a given input for the your AlexNet architecture. So there you see there are three channels, channel of the RGB images. So that's the reason red, green, blue. So there three has been added. Three cross 224 cross 224 is overall the image dimensions. Where you see 11 cross 11 is the kernel size of the first convolution layer. Okay, in the second convolution layer we are doing it for the 5 cross 5 size of the kernel, and then followed by 3 cross 3 convolutional layer. And you see here we are using the max pooling layer where you see after each convolution stages, those are the 3 cross 3 max pooling layer. Okay, instead of using the average pooling is being used in case of the LNet. AlexNet is using the last dataset first of all as an input, and they are basically taking the max pooling operations up after the each convolutional stage, and then obviously in the final stage these are the fully connected. Okay, here although the output has the 1000 categories during the AlexNet paper was developed, but to compare with the LNet performances we will use the MNIST dataset here. Okay, and our output will have the 10 categories from 0 to 9 for the defect detection purpose. So this was all about overview of the architecture. Now I am gradually moving towards the code section. Okay, so basically first of all what you do, you simply type the pip install mxnet and pip install d2l. So mxnet is the deep learning framework, okay, which has the huge support for the deep learning, all the deep learning architecture implementations. So basically even Amazon Web Services, AWS, and other online huge database platforms, data driven platforms basically use mxnet. And d2l will also install the d2l. It will give you the all the unnecessary avoidance of the downloading modules and all those things you can avoid related to deep learning platforms. So it always stays updated with the current version available in the mxnet. And then from mxnet import np and npx. NP for the numpy, and npx is makes you the version independent of the Pythonic platform. Whenever you are taking support of the Pythonic platform to implement deep learning codes, you may require to download the necessary modules and all those things. But there can be some discrepancy may happen due to the unnecessary download of certain modules and all those things. Those discrepancies can be avoided with npx. And then what you do from mxnet, you call the gluon library, and from there import nn, neural network. Okay, and from d2l import mxnet as d2l. Okay, then you just make the basic setup, net equals to nn dot sequential. So here what we are doing, we are basically using the larger window of the kernel first step, because we have seen in the first step, if you see the architecture of the used in case of the AlexNet, that is 11 by 11 convolutional layer. So what you do, you just go there. Okay, and what you will do whenever you are defining net dot add. Okay, so in case of the net dot add, what you do, you write nn.conv.2d, 2d convolutional layer you will use with the stride of 4. So what you will define that in output it will be 96 channels. Okay, kernel size define 11, and then you define the stride is equals to 4, and activation function is ReLU. ReLU is the activation function for the deep learning. And then in the next step, what you do is you use the max pool. Okay, max pooling layer. So in the max pooling layer, you put the pool size 3, because already we have discussed the kernel size, window size for the pooling operations will be the 3 cos 3, and the stride will be 2. So splitting the stride 2, what will happen? It will make your convolutional window smaller, and then we can put some padding to make the consistency between the height and width of the windows, okay, and increase the number of the output channels. So then what you can do, you can keep nn.com 2d to the channel, your basically the channel size, kernel 5, so we are putting equals to 5. We are doing to maintain the consistency of the height and width. Activation equals to, okay. Then in the next step, nn dot maxpol. So again, we after the doing the convolutional layer, again you are calling the max. So max pooling layer, our kernel size is 3 cos 3. So pool size will be 3 with strides 2. So what will happen that this in this way you can go and implement this successful convolutional layer and with the comparatively smaller window. Then at the final stage, what you are doing, nn.com 2d, okay, where the kernel size will be 3 because there will be 3 cos 3 kernel sizes for the convolutional layers, 3 convolutional layers, where the padding is 1 and the activation, as I told you, we are using ReLU. And then finally followed by the nn.maxpool 2d, okay. So pool size will be 3, stride equals to 2, and then followed by what will happen, there will be the dense layer, okay, because we are forming the fully connected layer at the final stages. So the channel will be 4096 with activation 2D, and there will be adding of the dropout. We are keeping the end of dropout 0.5 in order to avoid some sort of the overfitting. So dropout plays a very important role in to avoid the overfitting. So and then final stage nn.dense 10, which will give you the output. As I told you that we are using the fashion MNIC dataset instead of the using the 1,000 classes of used in the paper or original paper of the AlexNet, in order to avoid the complicacy, okay, because it will take a lot of time to run the code, because we want to run the code within few seconds. So it is better to go with the fashion MNIC dataset to for the initial learning purpose. Then whenever you will dealing with some complicated research problems in your research lab, you can put execute those type of the classifications with 5,000 or 1,000 levels. But it will take a day to run the whole code, okay. So after once you incorporate it, there will be run cell button. Once you click it, you will be able to see the output like following. The output we are getting, the collecting MXNet, downloading the required version of MXNet and downloading D12, and it will show the all the installations and all those things has been done, okay. So this is how you can do the first portion. In the next portion, we will do the next part of the with our relevant tasks. So I request all of you to type this code and run this code, okay. So should I share this particular code in your comment box section? I think it will be better for you to run the code, I guess. Okay, so let me do it. So kindly check your comment box section. I am sending you the code. Please make sure that you are copy pasting it in your collab, okay, to run the code.
Yeah, you're sending one more?
Yes, I am sending the next part of the code. Just kindly.
Yes, yes.
You see, the full format of the code has been sent to you in the comment box section. And now I am sharing the screen. Make sure that you are adjusting the spaces. Okay, proper spacing of your code by looking at the screen. Because you see, in case of the any Python or Pythonic platform, you have to be very careful about the spaces or indentation. In technical language, we call it the indentation. So look at the top. Okay, look at from the top. I will gradually, slowly go down. Okay, to the next portion of the code. So you make sure that you are putting this proper spacing, okay, and proper alignment like the code is there, because I tried to set whole code in comment box section, but once at a time it is not going there. So I have to send you in few parts. So make sure that you have adjusted those spacing properly, because in other programming language what happens, that indentation error, what we call, it people uses the spaces to move to look the programming much more stylish or coding much more stylish manner. But in any Pythonic platform, the indentation is an important part. In case of the Python or any Pythonic platform, you cannot put unnecessary spaces, which may lead to error, indentation error. And also make sure that while copy pasting the code in your Colab, you should not have some syntax error. You may happen that due to you may have deleted one word or something like that. So which will happen, or which may lead to the indentation, sorry, syntax error, or all those things may happen. So try to avoid those things, and make sure that there are some comments has been added with the hash sign. Okay, make sure that those hash signs should not be removed, otherwise it will give you error. So certain comments to explain the certain steps, those who are new to this particular domain, it will be easier for you. That's the reason those comments are added with these codes. So make sure that you are not deleting it. Okay, it will be keep it as it is there, but make sure that you are adding the spaces properly. Okay, and check the proper alignment of the code. That's the reason I have shared the screen with all of you. Okay, so make sure that you have make the proper alignment of the codes. Each line of the codes you have made the proper alignment and maintain the proper hierarchical approach, and then click on the run cell button to run the code. Okay, it will start the execution. Once you finish it, just let me know. It is 12:38. I hope that you can complete it by 12:40. Okay, because all the code is with all of you. Just make sure that you have aligned it properly and you are running it. So look at the screen, align the code properly, and just click on the run cell button and run it. And let me know once you are done. Then we will go to the next portion of the AlexNet architecture. Okay.
Yeah, sure. We are working on it.
So is it working? Just kindly let me know. You can write it in comment box as well. Okay, that if it is working, or you can unmute and let me know that you are able to run it. Kindly let me know. Huh? Once you are done, just write in the comment box section that you have successfully executed it. Have you been able to execute it successfully? Can you write in the comment box? Okay, executed, sir. Executed, sir. Okay, install success. Okay, thank you. I can see that most of you already have executed it successfully. Thank you very much. So we are moving to the next part. Okay, so we are moving to the next part. So now what we will do, we will basically construct a single channel data example, okay, with the height and width of 224 to maintain the out of shape of the each layer, okay, as given there in the architecture, okay. So basically what will you do, we will use the 224 by 224 shape, okay. So first of all, what we'll do, we'll basically put np.random.uniform. That means from the uniform distribution, we will collect some random samples and then we will form a numpy array. Okay. So then what will you do? You will basically print it. Okay. Assigning the capital X equals to layer of X. You just print layer dot name output shape. Okay, put some tab will give you some space, okay, and then x dot shape. So if you print like this, your output will look like this, okay. Each step of the convolutional layer and pooling layer, you are getting this type of the output, okay. So for example, the number of the layers, channel, and dimensions, output dimensions, 54 by 54, 26 by 26. In this way, the output dimensions you will get the number of the layer, channels, and the output dimensions, okay. So this is how you can uh, this is the way you can print the output. So first of all, what is the layer dot name? Your layer name con 0, pool 0, or con 1, pool 1, up to dropout 1 or dense 2. In this way, the layer name will be there. Then output shape, you will put slash t because you want to put some slash tab will help you to put some space between the output shape and the original shape size. So output shape colon, and you are putting some space and then your x dot shape, okay. So this is how output will look like, okay. So I am just putting the following code in your comment box section, okay, so that all of you can able to run it. Once you are done, just let me know. Send it to your comment box section. So please execute it and let me know. So we'll move to the next part. Okay. So this is 12:44. Please try to complete it by 12:45. As I have told you, that make sure that you are maintaining the proper spacing indentation in Pythonic platform. Okay. So once you paste it in your Colab, just cross check with the screen. I have shared the screen with all of you that you have maintained the proper indentation, and then you click on the run cell button, you will get following type of output. Okay, conv 0 output shape, pull 0, conv 1, pull 1, this type of output you will get. Okay. So once you are done, just write in the comment box section. Then we will go to the next step. Okay, done, sir. Okay, thank you all of you. So I will do the next step. Okay. Now what we will do, we will do the read. Okay. So in the reading data set, what will happen that as I told you that we are executing the MNIST data set rather than the data set has been used for the ImageNet competition purpose in the AlexNet paper. Okay. So here, what will you do? We will basically use the 280 by 280 pixel. Okay, for the ImageNet images, because we are taking the lower dimension, but to match with the architecture, we have to upscale it. Okay, so what will you do? We will resize it with the d2l dot load underscore data underscore fashion underscore MNIST function. Okay, here we will put two arguments. Okay, so batch size and resize. Resize we will do 224 because we will deal with the 220. We have to match the according to the architecture wise 224 image size, and the batch size has been given as 128. Okay, so batch size means the number of the samples or images you are using for the each iteration of training. Okay, or each epoch of training. Okay, so what I am doing, I am sending this part to your comment box section. You just make sure that you are being able to run it. Okay, just let me know. Let me share it in the comment box section. Once you are able to run it successfully, just let me know. Okay. It is 246. Just two lines of code. Make sure that by 1247 you are able to complete it. Okay. It's now 1246. By 1247, I am requesting all of you to complete it. Okay. So then we will go to the next portion. So it will, in the next portion, we will discuss about the training section. So we will start the training of the AlexNet. So compared to LearnNet, the main change is that we will do it in a little bit of smaller learning rate, and the slower training due to the much more deeper and wider network. Okay, and the higher image resolution and the costly convolutions. Okay, due to that, it will take some time for the training and giving you the competitive landscape of the training and testing accuracy. Okay, so once you are done, just let me know. We'll go to the training portion. Okay, done sir, done sir, done sir, executed sir. Thank you very much. Thank you all. So we are now moving to the training section. Okay, so you see in the training section, we have done. The defined DLR landing rate equals to 0.01, comma number of epochs. We have kept it as 10. Then in the next line, d2l.train underscore ch6, we have kept first argument net, comma, comma, test iter, comma, number of epochs, LR, comma, d2l dot try GPU. Once you execute it, it will give you the detailing of the accuracy. Okay, so you can see the training accuracy 879, that means 87.9%. testing accuracy is 0.886, that means 88.6%. Okay, and this type of the curve, if you reach, if you the training, but the training accuracy and testing accuracy, you can, okay, there's a clearly you can view the training accuracy and testing accuracy, and you see the training loss which has been executed with this continuous blue line. Okay, so here you see with the number of the epochs increases, the training loss is decreasing gradually. Okay, and with the green dotted line and the pink dotted line is showing you the testing and training accuracy respectively. Okay, so this type of plots you will achieve once you execute this part of the code, but let me tell you, it may take several hours to run. Okay, so don't expect that it will run within the few seconds. It may take several hours to run. If you have other tasks to do, you may leave it as it is running. Okay, it may take 8 to 10 hours even. It may run it within 2 hours. It may take 8 to 10 hours to run this portion. Okay, so that is the thing I want to tell you. Okay, so it will not give you the result very soon, like you have got for the earlier portions. So you just copy paste it and run the execution. But anyway, this type of output you will get once the running portion of the code is completed. This type of the output you will achieve. Okay, so in the I have sent you the description of the code in your comment box section. Make sure that you are running it. So in a nutshell of the AlexNet portion, you can see that AlexNet has a similar architecture of the LeNet, but it uses the much more number of the convolutional layers and larger parameter space to fit with the properly fitting with large scale image net set. Okay, and AlexNet, that's the reason it has become the much more effective architecture, and it after that the new era of the deep learning has started. So AlexNet's success is very, very significant. Okay, and although it seems that there are very few lines of the AlexNet implementation than the LeNet, but if you look the overall impact of the AlexNet due to its successful experimental result, you see there's a reason it has boosted the confidence of the deep learning community. Okay, people started relying on the deep learning. Like I mentioned that when the LeNet came up, even support vector machine and other machine learning algorithms can outperform the LeNet performances, because in those time you don't have that type of the hardware supports or the software framework related supports to give the adequate performance for the LeNet. But as per the developments with the time, with the software performance, software framework support, and the hardware development of the semiconductor industries, you can see the remarkable achievements can be achieved in the era of the deep learning. And even you see whatever the hardware support we are getting, the database is getting double day by day, and the exponential growth of the database. By 2035, whatever the nowadays hardware support we are getting, that the performance will be saturated. So that's the reason we are gradually moving towards the quantum domain. Nowadays we are talking about the quantum machine learning and all those quantum platforms. So we have to achieve the quantum support within 2035 to get the robust support in terms of the computational aspects. Okay, so dropout, value, and preprocessing were the key steps for any deep learning framework architecture. Okay, so I hope that now after doing particular session, all of you have got the lot of confidences related to the AlexNet. Okay, so it's 12 already 12:53. So ending up the session towards we are going towards ending up the session. So if you have any queries or question, you may ask. I will share this notebook to all of you. Okay, at home you can practice, and all theoretical essences as given there. This text portions you will get. You can go through the text portion and you can enrich your knowledge. Okay. So let me know if you have any doubt or queries. Otherwise, because it is already 12:55, so I have given the 1 hour time to conduct the whole session actually. So in the next time, whenever I will get the much more time, for example, 2 hour or 3 hour session, so we will talk about much more advanced deep learning architecture and all those things. So I believe that this portion of the code is already running for all of you. Actually, it will take some time to give you the graph. Let me tell you. Okay, it may take 8 to 10 hours even. So, but I believe that the basic funda has been now quite clear to all of you. And all of you, those who are expert already in this field, they already know everything. But those who are new to this field, now I believe they are getting the confidences that how to execute the codes to implement successfully the modern deep learning architectures like AlexNet and etc. etc. Okay, here we have done the AlexNet.
Yeah, thank you, sir. So, will it take more time, as you said? So, because
Yes, yes,
we are.
yes, 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 madam. It will take
Okay.
even it may take even 8 to 10 hours. So
Oh,
you just but the notebook I will share to all of you. So you will achieve this type of the output at the end. If you are able to give such type of the time span to your machine, you will be able to see this type of output. Okay, but this notebook will be shared to all of you, so nothing to worry about it. Okay, all of you
yeah.
will be able to go through the theory part as well, whatever written there. I have already highlighted those part, but you can study it. So should I stop the screen sharing?
Yeah, yeah. Thank you, sir. Actually, we have completed up to what you have sent, but output, we will look into it.
Output will take some time. it
Yeah,
will it will
yeah.
take some time, even 8 to 10 hours. Okay,
Okay, fine.
and
Thank you.
those who want to contact with me, you can send me email. Okay, here regarding your support related to any data science domain, right from the machine learning, deep learning to quantum machine learning. If you need any support from me, you can write it here. I am sharing my email ID in your comment box section. Okay.
Yeah. So, I request
I have
Dr.
shared my
Parvati.
email ID in the comment box section. Please,
Yes, sir.
madam, carry on.
Thank you, sir. We will. Thanks for sharing your mail ID. I hope sure our students, faculty members may contact you on
Okay.
these queries. Thank you so much. I now request Dr. Parvati Madam to give away the vote of thanks.
Yeah, madam. Good afternoon. Yeah, am I audible? Hello.
Yes, ma'am. Yes.
Yeah. Yeah. Respected Principal Madam, Dr. Kevian Sunita Madam, respected Chief Guest and today's session speaker, Professor Sabyasachi Mukhopadhyay, respected heads of the department, dear faculty colleagues, and the student participants, and my dear all the participants. On behalf of R&D team and the entire fraternity of the BVRIT Hyderabad, I extend a very hearty vote of thanks to the chief guest who spared time from his busy schedule to grace the occasion. I thank you, the speaker, for gracing your crucial work and sharing with us your ideas, explanation of everything, your opinion and findings in the presentation. And it is wonderful insight of the Kolaghat hands-on too. Further, a big thank you from my bottom of the heart to the management, our beloved Principal Madam, Kevian Sunita Madam, for her continuous encouragement in all the occasions for making the event successful. And my sincere thanks to in-charge R&D Dr. Kayal and her team who brought the reality of the session today with her efforts. I extend my hearty thanks to all the heads of the department who encourages their faculty to become part of this today's event, making it successful. And I also thanks to all the faculty and student participants for their cooperation for joining this event. I thank each one of you for making this event successful. Thank you, Ananda, for the opportunity.
Thank you, ma'am. Thank
Yeah,
you,
thank you.
Professor. Thanks for joining us today. Thanks for enlightening us, and hope our collaborations will continue in future as well. Thank
Small
Yes.
request, everybody unmute your videos, please, to have a session photo. Along with the speaker,
Yeah.
everybody please unmute your videos once. Still, some people have not yet not yet unmuted. Please do that immediately. One second. I'm taking the picture. Yeah. From my side, it's done, Kyle, madam. I've taken
Yeah,
picture.
yes, sir. Thank you.
Thank you, Anand.
Thank you. Thank you very much. Thank you, sir. Thanks.
Thank you very much for your kind invitation. It will be my pleasure to come in your as a guest speaker in your future events, and obviously I am thankful to all the participants for their active participation, because you see, hands-on session in remote mode is very difficult. It is not at all possible without the cooperation from your side. So thank you very much all. I believe that from this session all of you got some idea about the AlexNet, and it will help all of you in your future to pursue the successful research in this direction. Thank you very much to all of you. Thanks a lot
Thank
for
you,
the
sir. Thank
invitation.
you. Really, you have enlightened us. Thank you very much. See you. Thanks.